Have you ever kicked a ball or thrown something and wondered, why doesn't it just go in a straight line? It always makes that curve, right? Well, today we're going to get into the story of a football that just refused to fly straight and the super simple physics that explains it all.
So let's set the scene. Our story starts somewhere we've all probably been, a school sports day. You know the vibe, the energy's high, everyone's cheering, and it all comes down to one big moment.
Okay, so picture it. There's a player, Rahul, and he's lining up a shot. The goal is right there. He takes a running start, connects with the ball, perfect thud, and sends it flying. Looks like a pretty standard, powerful kick. But then you notice something. The ball isn't zipping through the air like a laser beam. No way. It's arcing. It's making this really beautiful, curved path. And that right there, that's our big question. Why? What's making it do that?
Well, lucky for us, Rahul's physics teacher, a Mr. Sharma, was watching from the sidelines, and he knew exactly what was going on. Turns out it all boils down to a pretty fundamental idea in physics.
The whole concept has a name, projectile motion. Now, I know, that sounds a little textbooky, but the idea itself is actually really simple. It's just the rulebook for any object that gets thrown or kicked or launched into the air. The second it's airborne, this one powerful invisible force completely takes over.
Mr. Sharma explained the secret. See, it's not just one force pushing the ball along. It's actually two things happening at the very same time. The instant that ball left Rahul's foot, it had two different speeds, or velocities, going in two totally different directions.
Okay, so think of it like this. You've got two forces battling it out. First, you have the horizontal velocity. That's the powerful forward kick, trying to send the ball straight ahead. But at the exact same moment, you've got the vertical velocity. That's the up and down part, and it's in a constant tug of war with gravity, which is always pulling that ball back down to earth.
So here's the bottom line. The ball is trying to do two things at once. It's trying to move forward, and at the same time, it's being pulled down. And when you smash those two motions together, what you get is that perfect, predictable curve, a shape that physicists call a parabola.
Now, to make this crystal clear, Mr. Sharma broke the ball's whole trip down into three simple parts. These are the three keys you can use to describe any projectile's flight.
He called them the three key ideas: time of flight, maximum height, and range. You put these three together, and you've got the complete story of that football's journey through the air.
So first up is time of flight. And yeah, it's pretty much what it sounds like. How long was the ball actually in the air? From the second it was kicked to the second it hit the ground. You might hear sports announcers call this hang time. That's what we're talking about.
Next, we've got maximum height. This is the very top of that arc. It's that split-second moment where the ball stops going up because gravity has finally won that part of the battle and it starts its journey back down.
And last but not least, there's the range. Now, in a lot of sports, this is the one that really counts, right? It doesn't matter how high the ball went, it matters how far it went. Did it make it over the goal line? That's all about the range.
Okay, so understanding all that is pretty cool. But then, Mr. Sharma dropped a little piece of information that takes all this theory and turns it into an actual game-winning strategy.
He gave the students a little pro tip. He said, if you want to get the most distance possible out of your kick, the longest throw, the farthest shot, there's actually a magic number for the angle you launch it at.
And that magic number is 45 degrees. It is the absolute sweet spot. It's not too high, it's not too low. That angle gives you the perfect balance between getting the ball up in the air and sending it forward, which lets it travel the farthest possible distance.
So, now Rahul is armed with this powerful new piece of information. He's got a secret weapon. And you know what he does? He decides to put it to the test.
I mean, he didn't pull out a protractor on the field or anything, but he focused on that idea of a 45-degree angle. Instead of just kicking it as hard as he could, he aimed for that balance, giving the ball a bit more lift. He was putting physics into practice.
And what happened? Oh, it was perfect. The ball just sailed through the air, following that beautiful parabolic curve and landed right in the back of the net. Goal! And of course, the students went wild.
And that's the thing, right? It wasn't just a lucky kick. It was a goal scored because someone understood the predictable, powerful rules of physics that are working all around us, all the time. So now you're in on the secret. That perfect curve isn't an accident. It's physics in action. Which kind of leaves you with a question. Think about a basketball shot, or the water coming out of a fountain, or even a character jumping in a video game. Now that you know what to look for, where else can you spot this awesome curve hiding in plain sight?